In the last video, we talked about how when you have parallel lines and a transversal cutting through them, then the angles that we've learned about actually have a certain relationship. And so some of the angles will be congruent and some of them will be supplementary. And so the list of congruent angles is off to the left there, circled in purple. So anytime we have vertical angles, and again, those only need two lines to be formed, just like we learned in chapter 1. Anytime we have vertical angles, of course, they're congruent. We learned that. Their measures are equal. But now these new angles that we've learned about, corresponding alternate interior and alternate exterior, their measures will also be congruent, so we can set their measures equal. The only types of angles that we've learned about that are supplementary will be the linear pairs and the same side interiors. And so that means if you see those, you're going to add them up to 180. And again, we already talked about this in the last video. We also did example 1 in the last video, where we identified what kind of angle pair we were looking at, and that way we knew, are we setting them equal or are we adding them up to 180, right? So in the first one, we had alternate exterior angles, so they should be equal. So if one of them is 129, then the other one's 129. In B, we had same side interiors, and so they should add to 180. And so you could subtract the 81 that you see in the picture from 180, or you can make it into an algebraic equation and say x plus 81 equals 180 and solve it that way. All right, and so we did all of these in example 1 in the first video. We even did a couple in example 2, I think. Now I'm trying to think if we did. Actually, I think we did that on Zoom Monday. We did a couple of these on Zoom Monday. And so we're going to start here. And in fact, let me erase this and start over because I don't think there was a video for this. I think we just talked about it on Zoom Monday. So let's redo at least this example. All right, so just like in example 1, we have to identify the angle pair relationship, and we have to know, are we setting the two things that we see in the picture equal, or are we adding them up to 180? So in this first example, 2A, I see a set of alternate interior angles. These are alternate interior angles. And therefore, if we went back up to the first page, we would remember that those are equal to each other. So 8x minus 6 will be equal to the 50. So again, these two angles that I'm seeing in the picture, the 8x minus 6 and the 50, those should be set equal to each other because they're alternate interiors. All right, to solve this, we would simply add 6 to both sides. We get 8x equals 56. We would divide by 8, and our x is equal to 7. And that's all we're being asked to do, is to solve for x. In example 2b, those are alternate exterior angles, but those are also equal to each other. And so we would set x plus 93 equal to the 85. We would subtract the 93 from both sides, and we would get x equals negative 8. All right? So remember, all I'm doing is thinking about the angles that were on the first page and asking myself, should I set them equal or should I add them up to 180? And the first two were a set of alternate interiors, right here, and a set of alternate exteriors. So they do get set equal. Once we get to example 2C, we're going to see that we have a set of same side interiors. And when you have same side interiors, those are supplementary and should be added to 180. So if we have same side interiors, we're not going to set them equal. We're going to say 11x minus 6 plus the 120 degrees equals 180 degrees. Remember to combine like terms. This is your algebra skills here that you're going to use. And you're going to get 11x plus 114 equals 180. You're going to subtract 114 off of both sides. And you're going to get 11x equals 66. And then you're going to divide by 11. And you'll get x equals 6. Now you could always plug it in to the 11x minus 6 in the picture. If you plug that in, you'd get 11 times 6 is 66. And 66 minus 6 is going to be 60. So again, 11 times 6 minus 6 is going to give you 60. And if you think about then, does my answer make sense? It does, because 120 plus the 60 makes 180. And again, they are supposed to add to 180 degrees. Now, I think I mentioned this on Monday or maybe in a prior video where I said you shouldn't go by what a picture looks like. But if you actually look at that 120 and the 11x minus 6, look at the 120. That's clearly obtuse. Also, you know it measures 120, so of course it's obtuse. If you look at the 11x minus 6, this angle is less than 90 degrees. So it would make no sense to set them equal. You would never set an acute angle equal to an obtuse angle, right? That wouldn't make sense. So even though I don't want you to go by what a picture looks like, I do want you to use some common sense and say, well, would that really make sense to add them together when they clearly do not look like they have the same measurement? And of course the answer is no. It wouldn't make sense to set them equal. All right, in example 2D, however, we're looking at corresponding angles because we have one that's interior and one that's exterior, and then we have them on the same side of the transversal. So again, those are called corresponding. Now these are set equal, and also if you look at them, they almost look like they're equal, right? You're not supposed to do that, but I mean, that's not the best way to do a problem, but this angle up here is 110, and this angle down here actually looks like it's about the same, doesn't it? Now you should have it memorized that correspondings are equal, but in a fallback position, you could always say, well, what do they look like? Do they look like they add to 180 or do they look like they're equal? And they actually do look like they're equal. So we're going to take the x plus 113 and set it equal to 110. We're going to subtract 113, and we're going to get x equals -3. Also, don't forget, everything we're doing here relies on the fact that the two lines are parallel. And these arrows right here, these two arrows, the extra set of arrows that are not on the ends of a line, remember that these are parallel markings. If we did not have parallel markings, then we could not be doing what we're doing. In fact, we would have nothing we could do. There would really be no relationship at all. So the relationships we're working with depend on the fact that we have parallel lines. And every single one of these problems has that extra set of arrows in the middle, right? I'm pointing to them now. So even if it's just a single arrow, it's that extra set that's not on the ends that tells you you have parallel lines. All right, in example E, we have a set of vertical angles. Again, those angles don't even need this bottom line down here, right? They don't need that line. And so that means we're back to the angles we learned about in chapter 1, either a linear pair or vertical angles. And this happens to be a set of vertical angles because they're on opposite parts of an x. So that means the 5x plus 20 is going to be equal to the 80. And that's really the same thing we've been doing since chapter 1. If we see angles that are made from an x, right, this angle and this angle are going to be congruent. They're going to be the same measure. So we have 5x equals 60. We divide by 5, and our x is going to be equal to 12. And again, I said it out loud, but I didn't write it. It asked us to identify what we have, and we have vertical angles here. All right, finally the last one. The last one also does not need that top line, right? It doesn't even need this line. Those angles are being made from the bottom two lines. So anytime the angles only need 2 lines and not 3, then they're not the new kind we learned. They are the old kind from chapter 1. So if you were trying to make the angles that are in this picture, you would, again, only need this x right here. And these 2 angles right here are next to each other, okay? So if they're next to each other, those are called a linear pair. And so a linear pair is the only other kind of angle besides the same side interior that we learned add to 180. So you'll take the 2 angles you see, the 17x minus 2 plus the 12x plus 8, and set it equal to 180. 17 and 12 make 29. Again, please combine like terms before you do anything. So 29x, the negative 2 plus 8 gives you positive 6. That's going to be equal to 180. And once you have your like terms combined, then you can start moving things. So now we'll subtract 6 off of both sides, and we'll get 29x equals 174. And then we'll divide by 29. And we're going to get, oh, I don't have my calculator with me. Let me think. 6. It's going to be 6. So 29 goes in 174 6 times. And so that's our final answer because all we were doing is solving for x. And I keep forgetting to write what we have. We have a set of linear pairs. All right. So one more time, let me remind you that if you have verticals corresponding alternate interior or alternate exterior, they're going to be equal to each other. If you have linear pairs or same side interiors, they're going to add to 180. Now I do have one final example because I think this example is kind of cool. This looks like, oh my goodness, I'm going to have a ton of calculations to do, but honestly not. You will not have a lot of calculation to do. So let's see what it's saying. It says find the measure of the indicated angles given that the measure of angle 1 is 40. So they're telling you the measure of angle 1 right here, this is going to be 40 degrees. And they're asking you to calculate 2, 3, 4, 5, 6, 7, and 8. And you might think, oh my goodness, that's going to be a ton of work. But it's not going to be a ton of work. Think about what you know already. You know, and let's start with the angles that are congruent because that's going to help you fill in a ton of these. Angles that are congruent are vertical angles, alternate interiors, alternate exteriors, and corresponding. And so angle 3 is a vertical angle with the 40, right, with angle 1. So vertical angles are congruent. Angle 5 is an alternate interior with angle 3, so it is congruent to the 40. Angle 7 is a vertical angle with angle 5, so it is 40 degrees. So just by knowing that 140, we also know that angle 3 is 40 degrees. We know that angle 5 is 40 degrees. We know that angle 7 is 40 degrees. And we already know almost half of what we need to know. Now the other angles are going to either be linear pairs or same side interiors. And so they're going to add to 180. So angle 2 and angle 1 are a linear pair. So 180 minus 40 gives you 140. Angle 4 is a linear pair with angle 1, so it should also be 140. Or you could have said that angle 2 was a vertical angle with 4, and that would make it 140. Angle 6 is an alternate interior with the 140, the angle 4, or you can say angle 6 is right next to angle 5. So there's tons of ways to double check yourself. Do you want to look at the linear pair or do you want to look at the alternate interior? In either case, you're going to end up with 140 degrees because 5 and 6 should add to 180 since they're a linear pair, but 4 and 6 should be congruent because they're alternate interiors. And so it all works out. And then finally, angle 8, to me, the easiest thing to do is those vertical angles. Angle 8 will be 140. And so notice that every angle that is next to each other is going to add to 180, and that all of our other relationships that are supposed to be congruent, again, our vertical angles, our alternate interiors, our alternate exteriors, our correspondings, should all be the same. And if you check them, they all are. So our remaining angles here are 140. 2 was 140, 4 was 140, 6 was 140, and 8 was 140. And this all relies on the fact that they're parallel again. So notice that extra set of arrows right here that I'm pointing at. Those are our parallel markings. And so the angle relationships we just focused on would only be true if we had parallel lines, which we do. And also notice there's only two numbers. There's 140 and 40 because that makes all the relationships we've learned about work. All right.